In this class, let us learn self-induction. Let us consider an inductor, a coil, which is connected to a battery. When the key is closed, current flows through the coil. Current gradually increases from 0 to maximum steady value. As the current through the coil increases, the magnetic flux associated with the coil increases. So an EMF is induced which opposes the growth of current through the coil. The magnetic flux through the inductor is directly proportional to the current through the inductor. So magnetic flux phi is equal to Li, where L is a constant known as self inductance. L is equal to phi by I. Its unit is Weber per ampere or Henry. The self inductance L may be defined as the magnetic flux per unit current. As the magnetic flux varies, an EMF is induced in the coil. The induced EMF is minus d phi by dt. Let us substitute for phi. Phi is equal to Li. L is a constant. So this is equal to minus L into di by dt. Therefore, L is equal to magnitude of induced EMF by di by dt. From this equation, the unit of L is volt per ampere per second or volt second per ampere. Volt per ampere is ohm, so ohm second. So L may also be defined as the induced EMF in a coil when the rate of change of current through it is unity. Now let us see the self-inductance of a long solenoid. Let us consider a solenoid of length L and area A, and let small n be the number of turns per unit length, that is equal to total number of turns by length of the solenoid. The magnetic field inside a solenoid is mu0 Ni and is parallel to the axis of the solenoid. Self-inductance is phi by I, and magnetic flux associated with the solenoid is N phi, where N is the total number of turns. So it is equal to N times B dot A. Magnetic field is along the axis. The area vector is also along the axis. So B and A are parallel. So magnetic flux is equal to NBA. But total number of turns is small n into L. And the magnetic field is mu0 Ni. Let us substitute. Magnetic flux is equal to mu0 N square Al I. Therefore, self-inductance is flux per unit current phi by I is equal to mu0 N square Al. So the inductance of a solenoid or a coil depends on the number of turns per unit length, cross-sectional area, length of the solenoid, and permeability. If the coil has a core of permeability mu, then L is equal to mu N square Al, where mu by mu0 is relative permeability. For a diamagnetic substance, mu less than mu0, For a paramagnetic substance, mu is slightly greater than mu 0, and for a ferromagnetic substance, mu is very much greater than mu 0. Thank you.